Lesson 3. Double angle formula. You can use the expansions of sine, cos, and tan of a plus b when b is equal to a to derive some formula. The sine of a plus a is equal to sine a for the first one, multiplied by cos a for the second one, then plus cos of a for the first one, multiplied by sine of a for the second one. And these two are equal, so it's equal to 2 sine a cos a. And so our first formula is sine of 2a is equal to 2 sine a cos a. For cos of a plus a, we know it's going to be cos of the first a multiplied by cos of the second a, subtract sine of the first a times sine of the second a. And so this is cos squared a minus sine squared a. Now there are two other forms that you can write this as sine squared a is equal to 1 minus cos squared a. This is going to be equal to cos squared a minus 1 minus cos squared a. And after expanding, you get 2 cos squared a minus 1. If instead we do cos squared a is equal to 1 minus sine squared a, then we get 1 minus sine squared a minus another sine squared a is equal to 1 minus 2 sine squared a. And so the cos of 2a is equal to cos squared a minus sine squared a, which is the same thing as 2 cos squared a minus 1, which is the same thing as 1 minus 2 sine squared a. For tan of a plus a is going to be tan of the first a plus tan of the second a over 1 minus tan of the first a multiplied by tan of the second a. And so we get 2 tan a over 1 minus tan squared of a. Let's do some examples. Use the double angle formula to write each as one trig function. So for part A, cos squared of 50 degrees minus the sine squared of 50 degrees. Part B of 2 tan of pi over 6 over 1 minus tan squared of pi over 6. And part C, 4 sine of 70 degrees over sec of 70 degrees. For part A, we know that cos squared of 50 degrees minus sine squared of 50 degrees is the same thing as the cos of 2 times 50 degrees, which is equal to cos of 100 degrees from this formula. For part B, 2 tan of pi over 6 over 1 minus tan squared of pi over 6 using the double angle formula for tan is going to be equal to the tan of 2 times pi over 6, which is tan of pi over 3. For part C, we can rewrite 4 sine of 70 degrees over sec of 70 degrees as 4 sine of 70 degrees. As sec is 1 over cos, dividing by sec is the same thing as multiplying by cos. So it's going to be 4 sine of 70 degrees times by cos of 70 degrees. And we can factor out a 2 to make it 2 sine of 70 degrees multiplied by cos of 70 degrees. And as sine of 2a equals 2 sine a cos a, we can rewrite this as 2 sine of 70 times 2, which is 2 sine of 140 degrees. Let's do one more example. Given that x is equal to 3 sine theta and that y is equal to 3 minus 4 cos of 2 theta, let's express y in terms of x only. Rearranging this, we can get sine theta is equal to x over 3. Rearranging this, we can get cos of 2 theta is equal to 3 minus y over 4. Cos of 2 theta is the same thing as 1 minus 2 sine squared theta. And so we can rewrite this as 3 minus y over 4, which is cos of 2 theta, is the same thing as 1 minus 2 times sine theta squared, which is x over 3 squared, which is 1 minus 2x squared over 9. Multiplying by 4, we get 3 minus y is equal to 4 minus 8x squared over 9. And rearranging, we get y is equal to 8x squared over 9 minus 1. And that is about it.